So what I did on that first video was I was actually graphing the result of the parametric equations. And so on this one, we're going to do more general, and that was on the unit circle. This is more general graphing. So for example, if they had graph x equals t squared, y equals t cubed, where t is between is greater than or equal to 0 and less than or equal to 2, your solution, now you have endpoints at 0 and 2, so you have to make sure you graph those. So I'm going to have t, I'm going to have x of t, and I'm going to have y of t. And x and y are both dependent variables, and the t is the independent variable. So if t is 0, then t squared is 0, so x is 0, and t cubed is 0, so y is 0. So we have this point 0, 0 in the xy plane at time t is 0. So that's our initial point, our starting point. And then we need numbers larger than t but smaller than 2 according to this. This is the domain here. The set of values for the inputs. So I put 0.5, and if you square 0.5, you get 0.25, and if you cube it, you get 0.125, which is an eighth. And then if you put 1 in for t, 1 squared is 1, 1 cubed is 1, so those all agree. 1.5, you get 1.5, 2.25. I'm just plugging it in these equations. Put 1.5 in there for t, you square it, you get 2.25. Put 1.5 in here for t, you cube it, and you get 3.375, 3 3/8. And then if you put 2 in, which is the other endpoint here, you get 4 and 8, which I put down here, 4 and 8. So I'm going to graph those points. In the xy plane, I'm just graphing the x and y coordinates, but I can label what the time is at each point if I want. So these are the actual points in the xy plane. You just look at the second and third columns. And the endpoints are 0, 0, and 4, 8. So I made my little scale matching these numbers, and I got that. So 0, 0 is right here, 0.25, 0.25 should be up here. Oh, this is 0.5, because these go by ones. So 0.25 is halfway between, but it should be at 1.5 here. Oh, I wrote that down wrong. It's 0.125. See from here. No mistake. So let's back it up. Make sure I have the right color. Point 125. There. Okay, sorry for that. Okay, now the graph should make more sense. So the endpoints 0, 0, and 4, 8. I put all my notches that I need. The horizontal scale, each notch is 0.5. The vertical scale, each notch is 1. So I got 0, 0, let's do this more slowly. I got 0, 0. And then I got 0.25 comma 0.125. So that's 1/4, which is about halfway between those two lines, comma 1/8. So it just goes up a little bit. And then 1, 1. Oops, I went too far again. 1, 1, which is this one right here. And then 2.5, 3.75. So that would be 2.25, 3 3/8. 3 3/8 is a little less than half, somewhere in there. Okay, and then the next one is 4/8. 4 and 8. And then we just connect these with a smooth curve. So it looks something like that, not super exciting or anything. Some of these curves are very strange. You can get like spirals and stuff like that, but usually you need trig functions in there somewhere for that. But anyway, that's what that one looks like. Note, always graph any endpoint. Those are always important. So if the endpoints come from this right here, right, from 0 and 2. Now, over time, remember what happens. You're at the origin here at time 0. Then you're at this point at time 1/2. And then at time 1, you're here. Time 2, you're here. I'm sorry. No, that's wrong. Time 0, you're here. Time 0.5, you're here. Time 1, you're here. Time 1.5, you're here. And time 2, you're here. So you're along this point, you're actually accelerating. You're going faster and faster as you go out. This is time 2. Say 2 seconds, just for the heck of it. Okay, so because now you can't tell that just by looking at the graph, but you can tell. You could sometimes people label them. You know, they'll say like t equals 1, 2, 3, 4. 1.5. You know, just label it right on the graph like that. Oops, kind of messed up my 5. Like that, right? But we just have this. Okay.